Solid Edge ST3 Integrated Design Environment accelerates existing user adoption by allowing you to maintain your existing designs using existing workflows or leveraging Synchronous for simplifying models or making improved unplanned changes. First, we're going to take a look at a markup of this existing part. In the markup, we're going to see that first we need to change the position of the hole in the center of the part. We also need to add 10 degrees to the vertical sides for added strength. We need to move the wall 15 millimeters along the edge and move the mounting holes out 35 millimeters along the edge. First, we're going to take a look at how existing ordered designs are maintained in Solid Edge ST3, just as you've always been used to doing in traditional modeling. In order to make successful edits to an ordered design, you must understand how the model is constructed. You must know the order in which the features were created. You must also know what type of edit that you want to make. We're going to cover some different examples and scenarios of editing this part. Remember from our design that we wanted to add 10 degrees of draft to the vertical faces. Since we don't have a feature to actually add that draft to, we have to create a feature in time. So we need to back up in time to the place where the cutout was created and add a draft feature. Also notice that I have to add this in 2 steps. I have to add the draft to the outside face, and then I have to add the same draft to the inside face. Once we've completed that feature, we can roll the model back to the end. According to our markup, the next thing that we need to do is make sure that our center hole aligns with the shaft. We also want to move the stanchions out 35 millimeters. In order to do that, we have to again roll the model back in time so you don't see the edits in real time or the impact on downstream features. All the dimensions are contained in the sketch. Because we use the feature playback to help interrogate the design, we're able to narrow down where the feature is that controls the edits that we require. In an ordered design, I can't just select the hole and drag it out 35 millimeters. You have to understand that the location of that hole is dependent upon this particular feature, that the center of the hole is located on the center of the end of this arm. One thing to keep in mind is that these sketches are dependent on the feature before it. So if the first feature changes too drastically, this feature could fail. Notice that we have to change the profile to change the shape. There's no direct control of the 3D geometry. The next edit I need to make is to pull this top section down to where it's even with the bottom of the bearing. Before I can do that, I need to know what the height is of this particular area of the model. I'm going to use a 3D measurement tool to measure this height. I'm going to save this distance in the variable table. Notice that it's 15 millimeters. This is going to be my top thickness. Maintaining this thickness is not straightforward in the ordered design. You have to understand that this particular model was made up of 2 different features. We have a cut coming up from the bottom, and protrusion 5 is controlling the height. I need to edit protrusion 5 and adjust the height, the extent, to the bottom of the bearing. Now as we look at that variable that I created, you can see that 15 millimeters has changed to 12.45. In order to get that back to 15, I actually have to edit the cutout coming up from the bottom. I'm going to select its dimension and actually subtract a formula to get back to the 15 millimeters. So you can see this was not a straightforward process to maintain that 15 millimeters and get the top of the part to the bottom of the bearing. Now let's look at how we can leverage synchronous technology to edit the same ordered part. It's also going to let us explore adopting synchronous technology on existing parts at your own pace. Moving ordered features to the synchronous branch allows us to have direct control of the model without having to understand how it was constructed or its feature dependencies. Notice that in synchronous technology we can add this draft or this 10-degree angle without having to add a new feature. I just simply select the faces and rotate them. Live rules takes the face on the inside of the part along with it. Notice we have control over the model. We can allow the geometry to take precedence over the change that we're making. Next thing we want to do is move the hole, so we simply select the hole. We don't have to worry about any dependent features, and Live Rules maintains all of the tangencies and the coaxial alignments. Lengthening the arms is as simple as moving the holes. Notice that we're altering the real design intent. We're actually physically moving the holes, not the related features. Live Rules ensures that the related geometry updates as well. Finally, we'll add a smart dimension to control the overall height of this top section. We're going to lock this dimension as we create it, which means that it cannot be changed as we make other adjustments to the model. So all it's left to do is to pull the top face down until it matches up with the bottom of the bearing. Notice that that 15mm dimension is maintained because of the locked dimension, so there was no need to subtract the base or mentally calculate the height. We can add design intent directly when it is known. So in conclusion, you can see that ST3 allows us to leverage synchronous for simplifying models and making improved unplanned changes.